This is where the rebuild really starts. Before Skip can measure or save anything, all of the dirt, oil, debris, and contamination has to be off of all the parts.
Is this going to be typically your first step of any repair?
This is the first thing you do. Get it out. Do a cleanup. All the mounting flanges like that, mounting surface, that'll be where a fitting mounts.
Okay.
You got to stone it. Get any hot spots off of it. So right here is the mounting flange where this pump actually mounts on the truck. You can see how rusted, pitted, rough it looks. So I've actually got to grab the grinder. So once we get it all cleaned up, you've got to go to the lap machine and make sure some surfaces are totally flat. This table rotates. You put your parts in these blocks, and there's a fluid that comes out here with mag grease. This is perfectly flat within a half a thousandths. So as that rotates, this aggregate drips out of here, makes it kind of like a really fine sandpaper. And we'll take the pistons, take them out of the ring. Then we have a bunch of blocks over here, old cylinder blocks. Actually acts as the weight. This is why you want to wear gloves when you do this, because you will get that stuff everywhere.
Oh man.
You can't get hurt.
So before we did what we did today, you tore it down and identified what was wrong.
Yep.
What was going on with this one?
This one had a bad shaft. Not all the ones we get in have these blocks on them. These blocks are made out of aluminum.
Okay.
And they have steel studs that go through to mount it. And the steel studs get corroded in here. I mean, really bad. We actually have to heat it with a torch just to get them out.
Okay.
So we replace the freaking hardware every time. So what you're looking for is gray coating the whole thing.
Okay.
Then you know it's flat. You got to get all that material off because that has grit in it. You don't want any of that to be on these parts when you go together, or over time it'll just grind stuff down.
From here on out is about precision, alignment, and preload, and making sure that all of the components go back exactly the way they're supposed to. One small mistake here could make for a nightmare on the testing bench.
That is the old shaft seal that came out of this.
Done for, I assume?
Yes. That's garbage. Keep in your pocket.
Good idea.
We're heading this way. All that. So all we're doing here is heating these races up.
Okay.
Just shrinking them up a little bit.
Gotcha.
Sometimes they fall out. Sometimes they don't. There it is. That bearing actually sits in that race. It's kind of how that operates, just like that. He's got a slide hammer. That goes in there.
That's freaking cool.
That's on the other end of the shaft. That'll sit right there with a bearing just like that. So right now we'll go remove this. You go over the arbor press. So you got to find something to build it up a little higher. You can see what was exposed to the elements and what wasn't. So we'll take that over the lathe, clean it up a little bit.
Okay.
Next, press these in. It's good to keep the old bearings. You can actually use those to press these in. So that'll just go down in there. And this one will go down in here. Beauty. So we'll take the old one. We'll drop that down in there and use that as a press. We'll take that old one, throw it in there and use that as a press. So both bearing races are installed. So now what we got to do is check our preload. So preload is the amount of squeeze you have on these two bearings because they oppose each other. So all the seal kits come with a spacer. So this is actually a slip bearing here. That'll slip on. There we go. So what we got to do, mount that in there. I'm gonna put the shaft in with no bearing or anything, or no seal or anything, just a shaft and that spacer. And we put the lid on. So, we got that down. Now what we got to look for, movement in the shaft. It's not supposed to have any movement and a little bit of drag on the, when you spin it, feel a little bit of drag. So now on this, one side has 2 holes, One side has one.
Gotcha.
Those two holes actually go through, all the way through, and are ported into here.
Oh, and
That has two holes. So that actually has to line up with those two holes there. Just take a Sharpie, make a mark where those holes are, and then actually take a same Sharpie and mark where those holes are. So when you press them in, you've got to line them up. All right, so this is the tricky part. See how that freaking wobbles?
Oh, yeah.
So you just got to have a very light touch. This is the swash plate. You can see how that rocks back and forth.
Yeah, I see that.
When it's full tilt like that, it's sucking.
Okay.
Sucking and pulling in oil. When it's like that, it's neutral. Not sucking anything in.
Okay.
So what happens is, if it's tilted, it's spinning like this as it's going around. It's pulling these pistons out, sucking oil in, going back to the other side, pushing them back in, pushing oil out. A little bit of oil in each bore. Makes it easier for the pistons to slip in. Cylinder block. So now what we got to do, pull this bag out, lay it on the side, and slip that in. Now there's a tricky part. These two plungers go on, and this, which we grease up very good, just because you got to turn this upside down and try to put it on here. And this stuff is just held in by gravity. So it can be a little sketchy sometimes. I actually like to do this by hand just because if something's misaligned, you can feel the resistance with your hand. You can't feel the resistance with that and you'll just crush it. But you can feel if you're crushing something. And you're amazed how you can crush something with just a bolt.
Yeah, it'd make for a bad day.
Yep. Ask me how I know. We still got to put the controls on it, or the compensator. That rusty piece of SOS. What it does is kind of controls the swash plate. It's the brains of this organization. Let's see. So what we got to do, replace those. Well, we've also got to replace these seal washers. So we've got to get an Allen in here. Little O-ring in there with a backup that needs replaced. I guess the last thing to do is put the seal in and put that block on. Because they get so corroded and stuck in here. So whenever we get them, we put anti-seize on them.
Pay it forward to the next guy.
Yeah.
Everything up to this point leads to right here. Once we hook it up to the test stand, we get to see if all that precision work translates into actual performance.
Once you turn it on, this just pulls the oil in, shoots it out here. So that'll go to like the cylinders or whatever. That's where the pressure is. That's just sucking it in, filling it up, and then it shoots it out here. Okay, so you know how I showed you the swatch plate moving from side to side? Here's your flow. Right now we're flowing nothing.
Okay.
If I have this shut off, so that means the swatch plate was even. Okay. Open that up, starts flowing. That means the swatch plate's still pulling one side of the pistons out. You're replicating a load on it, like if it's pumping oil out to a piston or something.
Okay.
So you put load on it and see how much you're still flowing. You put a 2,000-pound load on it, see how much you're still flowing.
Okay.
And then you check your RPM. So you take your load off, match your RPM, and see where your flow's at. So I was a gallon different.
Okay.
So I'm losing a gallon at 2,000 PSI, which is good.
And this is the payoff. What started as a broken, worn out pump is now tested, validated, and finished with a fresh coat of paint and ready to go back to work for the customer. Thanks for watching. Don't forget to like the video, subscribe to our channel for more kick-ass manufacturing and construction content, and leave a comment down below of what you want to see us rebuild next. See you next time.